system. And a lot of your three-phase panels will have a phase monitor to make sure that you have all three phases and they're working within the realm. A lot of the phase monitors are frequency sensitive. So if your generator is not really pulling at the full 60 cycles, and you can adjust that by the speed of the generator, you're going to have some phase problems with your phase monitors.
Are you saying to make a note of that when we go out on something that has a diesel generator or a gas generator? Is that something we should look at?
Yeah, if you're having problems where you're losing phase, we've had calls in for troubleshooting where we have people say, I get a phase monitor alarm every Tuesday at 2 o'clock. Well, the generator on that site would turn on and do its cycle for its exercising cycle, and they would get a phase problem because the generator frequency wasn't adjusted properly, and they only had 55 hertz of power, and the phase monitor saw that as a problem.
What does it do to your equipment?
To your equipment, it'll make your time clocks run a little bit slower. So if you've got an ETM, it's actually going to run a little bit slower on the generator than what it would the regular commercial power. When you run 60 cycle power versus 50 cycle power, the 50 cycle power will make your motor run a little bit warmer if it's not designed to be worked on 50 hertz. A lot of the motors and a lot of the stuff that we use in our control panels are rated for 50 or 60 hertz. The next thing that we like to talk about when we talk about control panels is amperage. And that's, I don't think this slide is in your packet there. This is the incoming power supply stuff, so let's get it. I think your next page in your packet says pump full load amps, correct? And the pump full load amps is provided by the pump manufacturer. And we use that pump full load amps when we size the panels for a couple different things. The first thing we use it to do is to select your protective devices. When we talk about the protective devices, we're talking about circuit breakers, overloads, and things like that are used to protect your motors. A circuit breaker in the panel, per National Electric Code, is sized 125 to 250% of that full load amps. So at Ohio Electric Control, when we size the starters for a case where we're looking at a pump, if your pump is pulling 10 full load amps, the circuit breaker would be sized at 13 amps. There's not a 13 amp circuit breaker in most cases, so we take that up one step to the next available size, which would be a 15. But we have the ability, if you look here, per the National Electric Code, we could go 250%. So a 10 amp load, we could actually put a 25 amp breaker on and still be within National Electric Code. The next thing we use that amperage is to select the contactor that's used in the panel. Does anybody know what the contactor does inside a panel? I know Ross knows. What's the contactor do, Ross? Yeah. The contactor is basically just a big relay that you use the 120 volt control through your hand switch or through a float switch to pull the contactor in, because it has big contacts to hold the amperage that the motor's rated for. So it's just nothing more than a big high power rated relay. And the contactor is sized as a continuous amperage. The IEC contactors, this is an example here of a 12 amp contactor. You want to make sure that that device is sized larger than the amperage that you're going to run the motor for. So if you have a 10 amp pump, you want to make sure that the contactor is rated at least 10, or the first actual value you'll see in IEC is 12 amps. Okay, the next device that we use that full load amps to size is the overload. And the overloads there again are selected based on that amperage. A lot of the older panels used to have a removable overload that you had a heater you put inside there, and you looked at a chart and figured out what size that heater needed to be. Then if you changed your pump, or as the pump got older started to pull a little bit more amperage, you'd have to change that heater. A lot of the new overloads that we see used in panels have an adjustment range. So we want to make sure that that 12 full load amps fits within the adjusting range of that overload. All of the overloads that we use for submersible motors are what is termed as a class 10. And a class 10 means that the overload will trip in 10 seconds if you pull 6 times the rated current through that overload. The overload is actually the device that protects your pump. The circuit breaker is mostly there to give you a means to turn it off and to give you short circuit protection instantaneously if there's a short circuit. Next thing I'd like to talk about is a couple of different devices that you'll see inside the control panels. And this first device that most people are going to see when they're hooking up panels is the power distribution block. That's basically the main incoming block where you're going to bring the power in to feed that panel. And we show a couple of different examples of the large blocks that we use inside our panels. The next block you're probably going to see when you're hooking up your float switches or any pilot devices that you have for alarms that are going out of the panel are these field terminal block connections. And in all of our panels, we use the marathon blocks that are a little bit larger. You can actually get a full-size screwdriver blade into those. It's just a little bit nicer feature, so you don't have to have those little screwdrivers to get in and mess with the panels when you're hooking up stuff. We talked a little bit about circuit breakers. The circuit breakers that we use in our panels are what they call a molded case circuit breaker. It's for an industrial use. And we see a couple different examples here. This white circuit breaker would be used for a 480 volt circuit. It's just a circuit breaker designed for that voltage. And in a lot of the residential stuff, you'll see these smaller black breakers, which are the what we call the quick lag series of breakers. And again, they're all industrial strength type devices that are used in the control panels. When you come to motor contactors, there's basically two, well, I'm going to say there's actually three thoughts you can use when you do those. The first of those is an IEC rated. IEC stands for International European Council. It's a manufacturing group over in Europe. They got together and set up this council so that they could set a basis for standards for rating of components. Here you see the IEC contactors, and down in this picture you see the overloads. This is actually one of the older overloads where you actually replace the heater packs inside there. And then this shows you an example of an adjustable one. It has a little dial on top there where you can adjust the amperage in for your base period motor. The IEC rated devices are rated based on the current that they can handle. So they'll have like a 12 amp or 18 amp or some amperage rating that they can be designed for. The next starter device we talk about is the NEMA rated starter. I'm sure everybody's heard NEMA before. And NEMA stands for National Electric Manufacturers Association. That's the United States-based organization that sets up the standard for electrical power. And the thing to know about the NEMA starters is most of them still have these replaceable packs, but they've switched now that the little device you stick in there actually has an adjustment rating on it. So you can actually adjust the ratings on those heater packs. This device is still selected by amperage. You want to make sure that you get the proper amperage that's running through that for your pump. But NEMA also has a requirement that you have to meet the horsepower rating too. So if this device is rated for 2 horsepower and you have a 3 horsepower pump that's only pulling 10 amps and the amperage is okay, you can't use it because it has to meet the horsepower rating too. The next important device that we use in the panels is a transformer. Like I said, if 230 volt single phase, chances are you're going to have a neutral connection, and you can divide your 120 volt controls by going from one of the lines to that neutral to get your control circuit. If you have 3-phase power, most cases you're not going to have that neutral leg pulled because you're going to have that delta configuration. In that case, we need to install a transformer inside to get our 120 volt control. It's sized per the load requirements. So the control section is going to take a certain amount of amperage to run. A lot of specs we'll see call out to have a GFCI receptacle. So if those devices are included in the panel, we have to make sure that transformer is sized large enough that it will handle that load for those devices. All of the transformers that we supply in our panel have a multi-tap primary. And what that means is on this primary side of the transformer, you can feed 208, 230, or 460. It's field settable. So if you buy a panel that's a 480 volt panel and you get it out to the field and go, I only have 230 volt power, it's as simple as moving the wire just one screw over, and now you've got your panel to work again. Perhaps one of the most important devices that you'll see in any of the panels is a fuse. And fuses are used to protect the wiring. So if you're using like a 16 gauge wire in your control circuit, you want to make sure that your fuses never go above 10 amp for a 16 gauge wire. My dad had this theory, he just kept putting in a larger size fuse until the fuse didn't blow, and then if that didn't work, you stuck a penny in and you were fine. So. But that's not the case. You need to make sure that the fuses are rated based on the wiring size that you have. And there again, they're sized per the load requirements. In a lot of cases, we'll have to size the fuse for the load we have, and then we select the wire to use with that fuse. The alternating relay is important if you're using a duplex station. Everybody, I'm pretty sure, is familiar with that. It just alternates the time between two pumps so that you're not running one pump all the time and the other one doesn't come on. All of the alternators that we use in our panels now have this little selector switch on the top. So if it's in the center position, it'll alternate between them. But if you have a pump go bad and you need to take pump 1 out, you can flip the switch over to pump 2, and pump 2 will always start first until you can put the other pump back in. This is probably a device that's becoming more widespread use today in control panels, the time delay relays, because a lot of the specs that are coming out require some type of a time dose. So you want the pump to be off for an hour and then pump for 5 minutes and then just repeat that cycle because you're feeding that down to a mound or some device like that that you need to time the dose on that. And they come in various different types, on delays, off delays, different things we use. In some cases, if you have large motors and you don't want them both to start at the same time, we'll put a time delay in so that we delay that lag pump. So if the power goes off in the panel and the wet well starts to fill, when the power comes back on, if both pumps are called, one will start, delay a couple seconds, and the other will start, so you don't have a big power drain. As we get more and more into classifications for wet wells, I'm seeing that they're calling out more for intrinsically safe relays. And what the intrinsically safe relay does in your panel is any wire that goes into, like the wet well is classified as a gas environment, it causes a non-sparking environment so that if something happens to the wire on the float switch, you're not going to cause a spark and make the wet well explode. Up here you see the couple different devices. We use the single channel device. They also make a 4-channel or 5-channel device. I like the single because if one channel goes out here, you replace this whole device. If one channel goes out here, you only replace one. Plus, if the on ISR goes out, you can pull the lag one out and move it over and plug it in where the on was, and your panel's back to working, and you can get another ISR to replace back into the lag position. You'll see control relays used in panels for a couple different purposes. To latch circuits on, to give indications for remote, run signals or alarm signals and things like that. So it's just little ice cube relays. I'm pretty sure everybody's seen them. We use IDEC in ours. We've used them for about 35 years and have had, I think, one relay go bad over the 35 years that we've heard of. So they're a pretty durable product. And there again, they're going to be rated at the 120 volts for your control. But the contacts on these larger relays, you can get a 10 amp rating through the contact. So if you need to run some type of a circuit through there, it will take up to 10 amps. Pilot lights are used in the panels to indicate some conditions happen. You have a seal fail or your pump's running high level or something like that. The device I showed here is the little neon light that we use in our panels. And the thing to know about this little neon light is it's not rated to stick on the outer door of the enclosure because it's not a sealed device. So if you stuck that out there and water could get into the panel possibly. So you usually see those mostly on the insides of the panel. They come in a couple different colors like you see, because we have some specs that want green for run, and amber indicates some other thing, alarm that's happening. This is a sample here. It shows you this is the oil type version. And the oil type version means that you can mount it through that door and it's going to seal up. It has a gasket that won't allow water or oil to get inside that control panel. Same use as the other lights.